Hey everyone, I managed to record today's fireside chat without any audio, so I'm going to try and re-record the tracing demo. Now, when I first started the demo, I gave a little bit of a caveat that this is something that came together very late. As of about 6 p.m. last night, I didn't really have anything worth showing, but I had some breakthroughs kind of late, and it has a nice visual component, so I thought it'd be fun. I'll just show everyone what we've got, and we'll see what you all think. So this is a setup called OTel tracing. OTel is something, a standards-based way of adding instrumentation to your code, not being tied to any particular vendor, gives you a lot of independence. And yeah, it's kind of popular and fun thing to work on recently. The product we're seeing here is from my last employer. So this is just a product I'm most familiar with, but again, not really endorsing that necessarily. It just happens to be a good tool to get started with. So, what is tracing? It's going to allow us to most commonly, take something like a user's request, some sort of identifier for a request, and then pull together all the events in the system that corresponded to participating with that request. Again, in a lot of complex systems, that could be multiple microservices that are all participating in serving a particular response. In the case of Fireproof, it could just mean tracing deeper into Fireproof, maybe going deeper into Pale, going into the Probably tree. Or maybe in the future it's going to be, we could use tracing to track things like how synchronization is working across multiple nodes in a more advanced topology. Those are all things where I think tracing would be a very useful tool to bring to the table. So what have we got so far? Well, I started with just sort of a basic integration of the OTel libraries that are out there for JavaScript, adding those to Fireproof and adding a little bit of instrumentation. Again, instrumentation right now is done manually, so it's something where you have to kind of pick and choose where you add it. And yeah, I'm just getting started. So let's take a look. I just chose a particular test case to instrument. It's in the database test. It's called Basic Database with Record. So this is a database that has, it's set up at the beginning to contain a single record. If we look at the setup function here, we see it's putting to a key called hello and the value world. And then that's the setup. Then when we actually run the test, the test we're going to run is called should update. That is going to do a put operation to that same key hello with a different value universe. And then we do another get on hello, again, just to verify that we get back the new value. So it's a very simple test. It's not doing anything particularly fancy, but I just wanted to use that as a way of illustrating what kind of information does tracing give us. So first you see there is these are what's called spans in the tracing terminology. So this has a start and an end. This corresponds to the should update, which you can think of as just that high level. That's the test case itself. So that's, in this case, taking 3.66 milliseconds. Now, we know that that's composed of other operations inside of it, right? So if we expand this, we can see I've sort of got it annotated such that the get operation on, the put operation on Fireproof and then the get operation, those have both been instrumented. So they show up here. Those are child spans, right? Because they take place inside of the should update. And those two are sequential, right? We first do a put, that takes some amount of time, and then after that, the get operation happens. So at the highest level, we would say this trace is starting to match our expectations of what we think the system's doing. There's a couple question marks, like some of these, the ends don't quite match up with what we maybe think they should be. And so, yeah, there's certainly more questions to be answered and a lot more to learn. But let's just keep following this and digging a little bit deeper. So we know the put operation is obviously composed of other things as well. One of the things we do is we write into a write queue. Now that's not illustrated, I didn't instrument that one. But then the write queue itself has to process, and that does happen, and it makes sense that that's taking longer because that's where the work actually happens. So we can actually expand write queue process, and we see that one of the things when we're processing the write queue, one of the things we do is we do a CRDT bulk operation. The CRDT bulk operation is comprised of a transaction, and then we apply something to the CRDT clock. We apply a new head once the transaction, sort of the outcome of the transaction. And again, we could go deeper. This could go into Pale, as I said. This could go into Probably tree for the CID set. So there, you could imagine this going much deeper, depending on what you're going to use this for. I'll just go ahead and expand the get operation as well. So if we expand get, we see that a database get is really just a get on the CRDT. A CRDT get involves getting a value from the CRDT, and then that value is still just a link to something else, right? So then we have to go get the value from the link. Um, and again, I would say this is not right. I don't think these are all happening like starting at the exact same time. So not doing something right still. But again, new library, just getting used to it with the JavaScript implementation. And this gives you a little bit of a flavor of what you can do with it. Now, I do want to highlight one other thing, which is that these spans are not just this nice visual representation. We can annotate them with data, right? So the good example would be the get operation. Actually, let's go to the database get operation. We know the database get operation takes a parameter, right? And that parameter is the ID that you're trying to get. And so that's a very useful thing. If you were debugging this, you might want to, and you were looking at this trace, you might say, well, which ID were they trying to get? And so we can annotate that, and I have. So here we see there's a bunch of standard attributes. OTel defines some standard attributes, and so those are showing here, sort of populating most of these columns. But then there's a facility so that you can add your own custom attributes. So I've just added a custom attribute called _ID. And that has the value hello, which we know was the key that we were seeing in the test case earlier. So that has the value we expect. Now that's a very simple one, and it's sort of straightforward, maybe not that interesting. But a much more realistic one is, in my opinion, when the value is sort of determined in the middle of the operation, right? So we know that when we did this get value from CRDT, that returned a CID, which is that's the link pointing to the value. And then we know in this operation, oops, sorry, I didn't mean to do that. Let's go back. We know that in this operation, it's using that CID because it has to go and fetch it, right? So if there was any problem, like maybe this was getting an error or something and we needed to diagnose it, we might want to know what CID is it. And so you can see I've been able to annotate this span with that CID. So here we see that if we needed that, you can just copy and paste that, take it to your tool and do whatever the next steps are in the debug process. So again, I would say this is I think a very useful tool. You can, like I said, annotate this with custom stuff. You can add some events and links to it as well. So that's kind of the gist of it, I guess you would say. The only other thing I would say is the other cool thing is this is all data, right? So this is data in a database. You can run queries against this, and that's, I think, where the real value is. We're going to be operating a cloud in the future, so you can easily imagine having like hundreds, thousands of these operations happening. And so another useful thing you can do with this is you can then use this to sort of like analyze that data, right? Find out that, say, maybe 1 out of every 1,000 CRDT bulk spans, is an outlier, right? And takes 10 times, 100 times longer than the others. Those are things you can find by just running queries on your traces. And so that can be a valuable diagnostic tool as well. So I'll stop here. I think you guys have seen kind of what I've been working on and get a sense of this. So this is something I think is cool for the future. So I hope you enjoyed, and thank you.